Question 3. A student investigates how the extension of a spring changes when different weights are hung from one end. Figure 6 shows the student apparatus. So this is just giving you information. Okay. It says which diagram correctly shows the forces acting on the spring. Okay, I'm going to underline that, on the spring. Not interested in that forces on the weight. Okay. So if I look carefully, I can see the forces. Okay, now the spring is not moving overall, so therefore it has to have balanced forces. So straight away you can rule out B and you can rule out C. So you're left with D and A. Okay, if you look at the forces on D, there's a force down there, but the force up on the spring doesn't come from that point there. Okay, the force upwards on the spring is at the top of the spring, so that's going to be A. Part B. Okay, so the figure is a graph showing the extension of the spring for weights between 0 and 4 newtons. So the weights are on the side here and the extension is going along the bottom. Okay, it's not normally the way we draw it. So calculate the spring constant using the information from the graph in the weight range 0 and 2.5 newtons. So you have to find 2.5 newtons. 2.5 newtons is here. Okay, it's slightly, I just zoom in, you can see it's between squares there, because each square is 0.02. So if I go along, I'll hit point here, and you can see at that point there, I should draw that with a ruler. I'll hit an extension of 10 centimeters. Okay, so I've drawn that on the graph. It's important to draw it on the graph. Now, calculate the spring constant. I know the equation, the force, is equal to the spring constant times by the extension. And you either use E or you use X. Either one, it doesn't matter. Both mean the extension. So the spring constant is equal to the force divided by the extension. So the change, well, it goes from 0 to 2.5, the force. And the extension goes from 0 to 10 centimeters. Okay, so there's a lot of people made this mistake of keeping it in centimeters, but the spring constant units are in newtons per meter, so you have to convert centimeters to meters. So 10 centimeters equal 0.1 meter divided by 100. Okay, so it's divided by 0.1 and the spring constant comes out as 25. Okay, some people just went ahead and put, oh, there's 2.5 there, there's a number of 10 there, I'm just going to times them, and they got the right answer. Okay, I don't expect that to be in the real exam, whether we'll allow that to happen. You'd have thought they'd choose the numbers a bit more carefully, but some people got away with it this time. Okay, so the next bit is describe how the extension of the spring changes as the weight increases from 0 to 4 newtons. Okay, so there's really 3 parts to this graph. The first part is a straight line, and then it's a curve, and then it's horizontal. So I'm going to label that 0 to 2.5, what's that, 0 to 2.5 newtons. The extension is, or goes up at a constant rate. And 2.5 newtons to 4 newtons, the extension is increasing for each extra Newton of force, and then 4 newtons onwards. Now it seems to just increase without any extra increase in weight, so it looks like the spring has snapped or become plastic. Okay, because you can see it's just continued to stretch. Part C. Okay, so here it's talking about a different spring. A different spring is stretched. The work done to stretch the spring is 4.2 joules. The spring has a spring constant of 23 newtons per meter. Calculate the extension of the spring. It says using equations selected from the list of equations at the end of this paper. Again, the candidate who's filled this in has just put some numbers in. Let's look at the questions on the paper. Okay, so we're looking for spring constant, and we've got the equation here. Okay, it doesn't take very long to just write that formula in. The best thing to do, E equals half k x squared, where x is the extension. Okay, so let's calculate the extension of the spring. So I've got to rearrange that formula. So I could put that under a triangle. E half k x squared. I want x, so x squared is equal to E divided by half k. Okay, so I put the numbers in. 4.2 all over half, I'll just put that as 0.5, times a spring constant of 23. And then, so I've got 4.2 divided by and that is 0.3652, and then to find out x I take the square root and it's 0.60 meters to 2 significant figures. Okay, I can't quote more than 2 significant figures because that's 2 and that's 2.